Today, Dion is going to show me how materials are stored in IFC. Are you going to do that,
Yeah,
Dion,
I
please?
am going to do it. Yeah. I will do it. So I'll go and import in my little 2 megabyte test model, which somebody gave me once upon a time, but it's really useful because it has all the things I need. So materials in IFC are really quite straightforward. And so today will be a nice, easy one. There are, if you do want to read this later on, the place to go to is the OSArch wiki over here. And under the list of how to learn about IFC, there's a link that says how materials are stored in IFC. And that will talk about the 3 ways, the multiple ways in which you can store materials in IFC. And by the way, today's topic will be materials in IFC 4. Some of these ways don't exist in IFC 2x3, and we'll talk about those edge cases at the end. But we'll start with the assumption that people are moving towards IFC 4 anyway, as they should be. So essentially, there is and also we'll talk a little bit about styles at the end of today's talk, because it's hard to talk about materials without also talking about styles, simply because many people mix them up, and IFC doesn't doesn't delineate it strongly enough, in my opinion. But basically, IFC has, just like it has classes for walls and doors and everything, there's an IFC class called an IFC material, and that is your basic that is your basic way of storing a IFC material. And the simplest relationship you can have is that if you have your object, so for example, this is a wall, and you have IFC material over here, you can assign that IFC material to that wall or whatever object. It really doesn't matter. You can assign it to any IFC element. And this is the most basic relationship that you can have in IFC for an IFC material. And this is called a single material. And just like most elements in IFC, a single material can have a name, a description, and it can also have something called a category. And there's no real rule of how you're meant to fill this in, but there are a few common ways that are suggested by the specification, like concrete, steel, or just leave it blank if it's not important. So in Blender, whenever you click on any object over here, the association between a material and an object is in the Object Properties tab. That's this orange icon here. And if you scroll down, you'll see the IFC object material. And this will say the material type. So the one I was talking about was this, the IFC material over here. And you can see that there are 3 other possibilities, or you can also have no material at all assigned to an element. Now, I don't know if there is any object in here which has just a single IFC material assigned to it, so maybe I can't show you an example. But if I did, if I did find one, you would find a material with a name. So in this case, it would have a name just like this, and it would have a description and category. You can see here the 3 attributes that I talked about, so I can give it a description. Obviously, default wall is not a very good material name. This is just something which came out of the BIM authoring program. And this is, again, symptomatic of the kind of level of quality that we often have to deal with when we're dealing with IFCs produced automatically by programs. Now, other than a single material, I'll talk a bit more about single materials. Materials can have properties associated with them, just like objects can have properties. And you know how for objects, depending on which class it is, like an IFC wall can have certain types of property sets. So in this case, it can have wall common assigned to it. In materials, it's simpler because there's just one class. It's IFC material. And if you go down here, you'll see a whole bunch of different property sets you can apply. So if I go to material common, I can go and put in the density of that material, for example. And they work pretty much exactly the same as the concept of property sets in that are assigned to regular IFC objects. So there's nothing too special over there. So hopefully all this should be not too foreign, and the fact that they can have attributes and they can have property sets. There is one thing you might notice that's missing here, is the global ID. And this is a little interesting fact of materials in IFC in that they are not what's called a rooted element. They do not have a global ID, and therefore it becomes a little bit harder to track. Well, not just a little bit, much, much harder to track. And some people, including myself, might call this a fault of IFC. So that's something you want to be mindful of, that in the future, hopefully this will change and materials will be trackable, as they represent a very important aspect of BIM. Anywho, so that's a single material. Now, there are 3 other ways you can assign materials to objects, and that's basically by combining materials into a group of materials or a composite material, and the jargon that IFC uses is what they call a material set. But basically, it means many individual IFC materials combined together in a composite. And there's 3 types of composites. That we have material layer sets. And if I give an example of a cross-section of a wall, so this is a wall, this is my ground, and we would have a layer of something here, a layer of something here, and then let's say a layer of stud work here, for example. And so this is made up of 3 layers. We have 1, 2, 3, and this is all standard stuff you expect in BIM programs. And to describe this layered materials, you would create what's called a material layer set. And so this would be one IFC material. This would be another IFC material that I just explained about. Oops. And then this is a third IFC material, and they would be combined together into a layer set. And it's pretty easy in Blender BIM. You create a layer set, and you can give it a name and a description. And again, these are not very good names and descriptions. But this should be all pretty standard practice. And then you can see here the list of materials. In this case, this is a layer set which only has 1 material in its layer, so it's not a very meaningful layer set. And each layer can have a layer thickness. It can have a name and a description. And by the way, this confuses some people. The name and description here is different to the name and description of the material itself. So if this name and description applies to the material, this name and description applies to the material layer, if that makes sense. So for example, the name of the material, if I go back here, might be plasterboard. And the name of the material layer might be something different. It might be outer lining or something like that. So hopefully that distinguishes the 2 different aspects. You can have multiple layers, and each one would have its own layer thickness. You're allowed to have a layer thickness of 0. For example, for things like membranes or paint finishes, things like that. And you can also say whether or not it's ventilated. And generally, that would be no for most solid things, unless it's air. There is also the concept of a priority. And so in a plan view, that would represent at a wall junction, for example, which layer takes precedence in that junction. So this is also, you should be familiar with this in how most BIM programs work. The exact same concept applies in IFC. The one with a higher priority overrides a one with a lower priority, and that's just a number. But you don't need to fill that in if that's if that's a complex detail or just irrelevant to your situation. So these are optional properties. And it also has a category. And again, this is a category for the layer, not the material itself. So just how the category for the material might be steel or concrete. the category for the layer might be things like load bearing or insulation or finish. And these come from the IFC specification recommendations. But you're perfectly fine to create your own custom category if you need to. So constituents is another type of composite material. And there's two types of constituents. One type of constituent is where you have something that's evenly mixed. So an example would be concrete, which has a whole bunch of different components in it. So for example, it might have a bit of cement, it might have a bit of water, it might have a bit of aggregate in it. And all of those things are mixed in a percentage amount. So for that, you can create a material constituent set, and it works exactly the same ways in layers, in that you can have multiple of them, and for each one you can have a name of the constituent. But instead of thickness, you would specify a fraction, which is the percentage through which that material makes up the whole set. And ideally, they should add up to 1. So if this is 100% brick, that would be 1. Not that this is a very meaningful constituent, but you get the idea. There is another type of constituent, and that's where something is not mixed together. So for example, a window. So here is a great example of one. You have a window object, and it has a material constituent set because it has two constituents. One is the glass and one is the window frame. And you'll notice that the fraction is set to 0 because it does not apply here. It's not a homogeneously mixed substance. So it's pretty simple, and you'll notice that this, for example, is the window frame portion of it, and then I can also select the glass portion of it. Ooh, that's a funky glass model. Shouldn't be like that. Anyway, so that's constituents, and you simply assign and because that type of constituent doesn't rely on percentages, you can just assign it to different parts of the model. So for example, if I had, let's say, this particular object here, let's modify this a little bit. So let's say this is some, I don't know, lining, who knows what. So I would simply create a new constituent, and we'll call this, I don't know, aluminum thing. And I would say, and I would go and assign it to this object, and I'll press assign here. I'll give it a different color just so that it's easier to see. And now back in the object, I would say, okay, there would be an aluminum constituent as part of this material as well. So hopefully that makes sense. And this might be trim, for example, if we could call that a trim. Don't know what you'd call that. Random thing. Finally, there is a profile set. And this one is a little bit not as common. What this one represents is, in the same way that you can sort of parametrically define layers, in that it has a layer of a certain thickness, then a layer of another thickness, and a layer of another thickness, you can also define profiles. So for example, if I had an axis starting here and going there, I can define a profile, say, of an I-beam over here, and that I-beam would be extruded along that axis, just as you would regularly have a geometry which does that in IFC, but instead you would describe it in terms of materials. And this is particularly useful if you're doing structural analysis. So for example, and we don't have any examples in this file, unfortunately, and it may not exist in 2x3. I'll have to double check that. But what it would do is allow you to define a structural frame model, and for each one of these lines, you would define parametrically the profile as well as their material properties. So I'll show you an example. So I can create a profile set, and for most simple structural elements, it would actually only have one profile in there. So we'll create, let's say it has Maybe aluminum is not very good. We'll call this steel. Again, it has a priority. And in this case, you would say, let's say this is a I-shaped profile or so on. And you can specify different types of parametric profiles to create your object. Now, this gets into a little bit of detail into creating structural models. So we won't go into too much detail today, but it gives you an idea that it does exist. You can also have multiple profiles, and this is useful when creating composite materials like this. And again, exactly the same concept applies. You'd add another profile in there, and you'd give it another parametric definition. Now, that should be a good summary of a material and the three ways you can combine them into composite materials. So a layer, constituents, the two different types of constituents. You have mixed constituents and explicitly set constituents, like a window glazing and a window frame, and material profiles. There are a couple more concepts to be familiar with, which is what we call a usage. And so, for example, if I go back to this material layer set, somewhere the program needs to define where is your axis of the wall. So, for example, if I extruded this wall out here, where is that axis starting, and where do these layers start and stop? So in this case, the wall is being swept along this axis, and the layers project out in this direction. And so that is called a usage. And it basically just says, okay, for this parametric layer, here is how it would actually work. And it's the same thing for these for profiles. It would say, here is an axis, and this is how the profile is relative to the axis. This unfortunately has not been implemented yet in Blender BIM as a UI which you can edit, so I cannot demonstrate it to you. But it is good to know that it exists. And you'll notice that there are two usages. There are layers and profiles. There is no usage for a constituent because it's not possible. A constituent is either completely homogeneously mixed, or it is explicitly set to geometry. It's not parametrically defined, and so there's no need for a usage in there. All right, cool. That's materials in a nutshell. Quick note about styles. A style is how an object looks. So an object may have a color, for example, or if you're rendering it, it may have certain rendering engine specific shaders. All of that information of the visual style of it is a separate concept to the material in IFC. So just because something looks a certain color doesn't mean it has a particular material assigned to it. And this can lead to a bit of confusion because, especially for architectural models, not so much with MEP, but especially with architectural models, you look at an object and you say, oh, it's a particular color, it must have its material data assigned. And sometimes that's not the case. So it's important to distinguish between the two. Everything you'll notice all the stuff I talked about just now, this name, description, they're all data. It's nothing to do with color. So just want to keep in mind that these are two separate concepts, and styles can have a lot of interesting properties assigned to it, which we won't talk about today. But for a basic color, it is possible to assign a style to a material. So what you may have is you may have an object, and you might have a material, and then you'll have a style, and that's assigned to this, and this is assigned to that, and therefore that's why the object takes on that color. It's also possible to bypass this, which is why I want to mention this, because that's why just having the color, this is where the color information, by the way, is stored. So just because something has color doesn't mean it has the material. But it is possible to set it through the material. In Blender, it's pretty simple. You just go to your material properties and you pick any color you want. But just wanted to clarify that they're not the same thing.
Sure.
Cool.
That sounds good. Let me ask you something very basic. Why it's important to get the...
Oh, why are we doing this anyway? What's the whole point?
Exactly.
What's the point of making sustainable buildings? What's the point of costing materials? Yeah.
No, tell me some useful
yeah.
cases. How might we use this information if we structure the files in this way, and if we put in the... when do we reap the benefits of it?
Well, the simple benefit is that you can actually annotate your materials. So somebody can click on any object and they'll know what material it's made out of. It sounds really simple, but if you give somebody a BIM model and it doesn't have material data in it, and somebody says, okay, I want to build this wall, what's it made out of? He won't know unless you have that material data stored in there. He won't know what the slab is made out of. That's why you got to put it in there.
Yeah.
But that's, I mean, that's pretty obvious. And we're already doing that in the closed BIM world, right? We add material data and we use smart annotations to tag or label or annotate material properties. But unfortunately, we don't, like the benefits are a bit obvious because they're in that closed BIM world. But once we start moving out of that closed BIM world and we start to annotate things from different programs or cost things from different programs or schedule things from different programs, that's where it becomes useful. Right? If a scheduler wants to take your IFC and he wants to know how many concrete piles there are, or coster wants to know how many concrete columns there are, concrete walls, and if you haven't put the word concrete in there or categorized it neatly, they can't do their job. And we're back to doing tracing off 2D.
Yeah. Okay. Is there anyone else who would like to ask Dion any questions? Please click on the hand on the left hand bottom side of the window if you want to ask something. Nobody? Come on.
Agron wants to speak.
Yeah? Okay.
I think you need to unmute.
Hi, can you hear me?
Yeah.
Hello, here we can.
Hi, Dion. Hi, the rest. I would like to ask a question about the thickness of the material. Shouldn't be inherited directly from the composite material because you have been inputting the thicknesses manually. So when I model something that has a certain thickness, shouldn't that be appended to the IFC material? And the second question that I have is, you were talking about property sets of IFC materials. Can you generate groups or sets of IFC materials, for example, for different types of concrete that can then be, with those specific property sets, be appended to my groups or layers that I will define? I hope that was, I think, clear.
Yep. So the first one was, shouldn't the thickness be automatically derived from the thickness settings in the material layer set? In theory, yes. In theory, yes, it should be. Although I think, I'm not sure if that's a hard rule in the IFC spec. I have to double check that. So it may be possible for you to disobey that. So when you're talking about a material layer set usage, there is definitely something in the IFC spec that I've read where it says that if I'm looking at a plan view of my wall, and if I draw another one here, and this is the axis of my usage axis, and it's being extruded out in this direction, then this dimensions should match the total thickness of all the individual materials in this material layer set. So in this case, is only one item, so 250, this should be 250. And that is definitely a rule in a layer set usage. However, in just a layer set, I don't think it's a rule. I think you can actually break that. I could be wrong about this, but I think there's nothing stopping you from modeling some funky wall and then only defining a material layer set for some of it. And if you haven't provided any set usage, then there is no, a human just has to interpret how he understands that layer set.
Yeah, but if you have you have just a part of the wall, let's say that this funky wall is one piece of object and you have different types of materials inside it. In my knowledge, then I would need separate objects to define those materials, because then I cannot do quantity takeoff, for example, or I don't know what is the total surface of that or cubic area of that certain material. And I don't know, if I check, for example, in an IFC file in Solibri, then if I click on a single layer of a composite wall or slab, then actually I can see also that in the IFC structure, there is, I think, a parameter that defines that single value. I will also have to check that out, but that's an interesting aspect.
Yeah. From my understanding, when you have a layer set usage defined, it's because of this particular restriction, and there are also constraints on the type of geometry. Like the geometry must have basically an extrusion out through the axis, which matches exactly this thickness. And because those constraints are in place, I think it's possible for the BIM software to calculate and actually draw this up. If I had more than one, it would actually, slice it into the different layers. And then, yes, it's possible for a BIM program. Blender BIM doesn't do this, but another BIM program, maybe Solibri does, to click on a single layer, and maybe it can then derive some additional properties. I know that the IFC OpenShell IFC Convert does do this operation. So if I converted that with IFC Convert, converted an IFC with IFC Convert, it will split up from a single object, as I see here, into multiple individual objects. But as a modeler, from my understanding, you actually do not need to model those. You can just model the mass as a whole, and then the rest is implicitly or parametrically defined via these properties here. And the layer set usage.
Mm-hmm.
Could be wrong though, and I haven't actually implemented layer set usage, so I might have made a mistake there. And when I do implement it, I'll be sure to correct myself. Hopefully that makes sense.
Yeah, but what about the groups in Blender BIM? Can you create these groups that define the one type of concrete and the other type of concrete, which has many property sets defined? So I don't need to actually click on each object and say, okay, these are the property sets and these are the materials and these are, you know what I mean?
Not entirely sure. But for example, if I go in, here I'm going to show my Poisson ratio, I don't know, 0.1, who knows? Is that right? Is that wrong? Whatever. So let's say I've assigned that to plasterboard, which is probably totally messed up. Then everything that I have set to plasterboard will automatically have that property set assigned to it.
Yeah, okay, so that's it, because then you have plasterboard 1, plasterboard 2, and 3, and 4, and they have then different Poisson ratios.
No, one Poisson ratio is assigned to this one IFC material. Mm-hmm. If I want another plasterboard, I create that, exactly, and then I would go assign it a different one.
Yeah.
What was the question?
No, actually, that's the thing, actually, because you create multiple plasterboards, like the 001, 002, and then you define the, what is it, Poisson or Poisson ratio.
Yeah. But you just define it once.
Yeah.
I don't see why you would create multiple plasterboards. You might create multiple layers, in which case plasterboard is mentioned twice. So for example, in an object, you might say, okay, there's 3 layers. You have a plasterboard, then a brick, then a plasterboard. And so both of these is the same underlying IFC material, which will both have this property assigned to it.
Yeah. Okay. But for example, if you have a property set, because this I think we have to differentiate where we define these property sets, because some property sets of a wall, we define it directly in a wall. And in this case, the property set is defined in a layer. So for example, the acoustic values, that's something that comes in a wall, or the fire property rating. But let's say the viscosity, or for example, in concrete, we have here in Austria something called the expositions class, and you differentiate your concrete. So it's still concrete, but it's a different concrete in different places.
Okay, I see what you mean. So this is the very simple scenario where you have a property set assigned to the material assigned to the wall, but you're saying, what if you had, let's say, a set of some kind, and you had a material, and you're saying that in this particular set context, the property set will be different. And so you're saying, because of that, you're going to have to assign, you have to keep on creating material 1, material 2, material 3. Good question. Let's check that. Good question. Good question. Oh, yes, I should also talk about this, the 2x3. In short, don't use 2x3. It's missing so many things of materials. I don't even know how people get by. Constituents don't exist.
Recording
they use something.
is on.
Oh, what was that? Funky sound. Constituents don't exist at all. They use something called a material list in 2x3. I think they're also missing super basic properties like, sorry, I'm getting distracted. I will get back to your thing, Agron. It's missing a whole bunch of stuff, like even, I think it's missing a name. Like you can't give a name to a material layer set. It's ridiculous. So for example, you won't find profile set, doesn't exist. Constituent sets are called lists. So you can't define things like percentages, I think. Yeah, that's right. You can't define, let's say it's 50% of material X and 20% of material Y. You can't do that in 2x3. For a layer set, you can get a layer set name, but you can't do a layer set description. And for a constituent, you can't even give it a name. So it's just too bad. No name, no description, you're stuck. There's no category as well. So you can't categorize things overall as being overall concrete or overall steel or whatever, or masonry or who knows what. So basically, 2x3 is missing a whole bunch of stuff. Just don't use it. Anyway, back to Agron's thing. This is a slightly annoying one, because from what I remember, the spec actually is missing the description of property sets assigned to materials. Yeah, that's right. This is a fault in the documentation, which has been mentioned but not fixed. So the issue is that they show how it assigns to objects, but they don't actually show the assignment to a material. So I will just double check here. A
Recording
material
has stopped.
is okay. This is what assigned is. This has properties. This is how properties are assigned to materials. So let's see if you can assign it to a layer set. And the answer is no. You cannot assign it to the layer set. And can you assign it to a layer? And the answer is yes. Okay, so you're absolutely right, Agron, that this
Perfect. That's
is possible. Sorry, this is wrong. My diagram here is wrong. Where's the erase tool? Is there erase? There we go. Whoops. Okay, so let me redraw this diagram just so other people can, in case it's a bit tricky to follow along because we went a bit fast there. I'm going to call this a layer or profile or constituent. So this is an individual item in the set. And now you can have a material. And now you can have the P set. And what we were just discussing just now is that it is actually possible to do this as well. Is that right? Making sense? Yes? No? It's silent.
To me, yes.
Okay. But this is actually, that's a really great point because I didn't pick up on that. And in fact, I have not built this in Blender BIM. So if anybody in the audience knows some Python and wants to help build this, please let me know. Let's build it. Let's do it. Because at the moment, you can't do it. And that kind of sucks. And it's actually really easy to build. So a nice beginner task if you want to get involved.
When I finish my Python course, I will help you.
Okay, great. Yes. let's build this together. Cool.
Well, is there any other question? We went over time, but if there are, okay, I see somebody. Mark Moss. Please go ahead.
But I was just wondering, without layering in IFC is great that you can make layers, but you lose somehow the connection with the BIM, right? So it's I'm not sure if you work with other BIM model tools, how you make a connection to all those IFC options. How do you edit? For example, if you work in Archicad, Revit, or something else, you want to fill it in your BIM modeling software and make a connection to the IFC properties. But I don't see any kind of a connection.
Yeah, so
it's just a solid wall, and you make layers, and you give them a thickness. Some IFC exporters will read it out and show you some layering. But where do you manage that in your BIM model? So if you make a wall in your BIM model and you define the layering and the materials and the thickness and maybe some other properties, you want to push them into the IFC, right? And to the right place in IFC.
Yeah, so I think that's more a question of how do you do it with a particular BIM software. So
no sound. Your sound is off, Dion.
Yeah, just.
Hello?
Dion?
Oh, okay. Sorry. I was on mute for some reason. Yeah, so I think that's more a question of how do you do it in your particular BIM program. And I kind of wanted to avoid that because that's a whole kettle of fish.
Yeah, that makes sense. So, but you were saying in Blender you don't model all the layerings. It's just one solid.
But that's not just in Blender, by the way. That would be in IFC in general, because the way Blender works is actually almost identical to the way IFC works, and with every release, it's getting even more identical. So yes, correct. You would model it as one big mass, and then you would define the layers, and that would be implicitly or parametrically defining the individual portions of it. And I mean, you've just seen me play around in the UI just now, and so and this one maps directly to how things work in IFC. So it's pretty easy to get the properties in here and translate it correctly. How you do it in especially proprietary BIM applications is a different story. And it's a really tricky story because it depends on which application you're dealing with, right? And some applications, simply the answer is you cannot. So for example, last I checked, you actually cannot assign material properties in Revit. It's just not possible. And that's a really sad situation for BIM. But unfortunately, there's no way around it. That might change after the new release is out, by the way. So this information could be a bit outdated. In ArchiCAD, I am not entirely sure whether you can or not. I haven't run through that process. But for those who do want to get involved and explain how to do all these things in different BIM programs, the place to go to is, again, today's meeting is sponsored by OS Arch, the OS Arch Wiki. And we have what we call a micro MBD, which is a way of checking exchange requirements. And we'll cover this in another session. But effectively, for different topics, and material isn't one there. It's still a work in progress. It hasn't been published yet. But for example, any concept in IFC, so let's take, for example, geocoding. So the ability to put address information into IFC. There's a section at the bottom. Oh, this one's not very well filled out. We'll get a better one. Geolocation. So let's say geolocation on IFC, which was the topic of the previous talk. We'll say, okay, with this particular BIM program, can you store all of this information in an export? And will it retain all the information in an import? And this is all of the information. So for example, can it store a coordinate reference name and all that type of stuff? And it'll give you various guides on how to do that. So for example, it would say, click this button, click that button, apply the setting, blah, blah, blah. So maybe that's what you're looking for. It doesn't exist yet on the OS Arch Wiki for materials, but you can help make that happen. And we can sit through, work it out. And when we have worked it out, we'll document it so that other people can figure it out too.
I'm just a little bit worried that if you have so many options and you have to fill in everything manually, you can also get mistakes and typos and so on, right? So, I prefer that the software reads it out somewhere and you not have to type it in. So that's.
Yeah, and in general, where that makes sense, Blender BIM is still very new, by the way. So many things in here are still quite manual. And that's the first step, right? The first step is you build the full set of fundamental tools. Then you kind of build workflows that automate parts of those tools, but you still retain the fundamental tools for the power users. And that's generally how the software evolves. And over time, absolutely, yes, like the ability to automatically read layer thicknesses and even bulk setting properties or visualizing properties is something that will come across. Anyway, all that will come, and still early days.
Okay.
And yeah, even things like predefined materials, layers. There was an interesting thing in the first topic. One of the early talks, we talked about project libraries in IFC. Now, nobody's really using that to distribute materials yet, although some people are starting to. So being able to have preloaded IFC materials with standardized attributes, or even ones which are part of a central database like the Building Smart Data Dictionary, all that will come, which will help in automatically setting correct data without people typing and making mistakes and having to check up, look up the spec and all those details. So it's exciting where this is going.
Yeah, it is exciting, and but I think the material approach is very promising, because we're in the Netherlands and we're just small group of people were thinking about how you define the materials. We had a lot of different materials, of course. If you only talk about concrete, you have all kinds of concrete, incast, prefab, a lot of different ingredients, material, how you call them. So, and if you want to do it in your basic BIM model software and you try to catch everything by the naming of the materials, it's not workable. So we think about, okay, what is a material, what should be in it? But in this approach, when everything is stored in the IFC, that's really powerful. So I think
Absolutely.
we have to, then you can call it in your BIM just concrete, everything is concrete, and in the IFC you define all the different concrete materials, the percentages of steel in it, and you can define everything there.
I think for those interested in this topic, there are two big things to, I guess, get rolling. The first is to kind of petition to Building Smart to make a material rooted, because once you add a global ID, all this kind of trackable stuff and central libraries and all that and standardization becomes a lot easier. The second is to get better support for what's called the Building Smart Data Dictionary. At the moment, there's still no support for that in Blender BIM, but that will allow you to basically load in predefined attributes, which are part of a central database. Maybe we'll talk about some other questions here just because we're almost finished. There's a quick one here. How do materials relate to the node-based materials in Blender? The answer is that that is actually not a topic of materials. That is a topic of styles. Remember how we talked about the difference between a material and a visual style? So a visual style describes the aesthetics, how it looks, and part of that includes something as basic as the color. It also goes to more advanced things like simple biased rendering shader descriptions like diffuse and metallic and things like that. And specular materials. It also allows you to specify physical properties. So those familiar with lighting simulation properties, like for example in Radiance, you would have not just a diffuse material, but you would actually define the diffuse reflectancy or ratios, and that can be stored. Let's just, but for those looking to use it for artistic purposes, which is more what the question was, because you're talking about node-based materials in Blender, the answer is IFC sucks for that, and it's like 50 years behind where the CG industry is. But the good news is that materials, styles, can reference an external definition. So you can actually link it to a Blender Cycles material, or a V-Ray material, or a RenderMan material, or whatever you want, and that way you can get the best shader tree for whatever rendering engine you like to use, and actually retain the link between your ArchViz and your BIM data. But that's a topic for styles, not today.
Okay, cool. I think we should wrap it up. We went to almost double time, so yeah. Thank you, Dion. Thank you, everybody, for joining. And see you again next week.
See you guys. Thanks.
Yeah, thank you very much. Bye.
Bye-bye.
Bye.